Hey everyone, Jason from Net.Academy. If you'd like to be notified every time we have new content, please subscribe to the channel and click the little bell icon. That's all it takes. Thanks so much for your support. Hi, thanks for joining us for session 2 of Practical OSPF for Network Engineers. My name's Jason. Let's hop right in. We have a simplified agenda today, but this will be a little bit longer than the last session. That's just because both of these topics are pretty key to how OSPF works. We're going to cover the different network types. In our case, we're going to focus on broadcast and point-to-point. And we're also going to cover different area types, stubs, total stubs, not so stubs. Let's focus on network type broadcast first. In truth, almost all your OSPF networks these days will default to broadcast, but we're going to talk on the next slide about a special case when we're going to want to change that default behavior. A broadcast, or really the network type in general in OSPF, is based on the type of interface that is configured for OSPF. If you are configuring an Ethernet interface, it's always going to default to broadcast. You can override that at the interface level by changing the IP-OSPF network type to a different type. But by default, it will be broadcast if it's an Ethernet. Broadcast is really meant for kind of like multi-access broadcast type networks, such as Ethernet, but really more Ethernet in terms of a LAN campus where I might have a broadcast domain with several routers on it, kind of like what we've drawn out here. You see a switch in the middle and a total of 5 routers, right? So it could get pretty inefficient and chatty if everyone's flooding all the time, right? And it would probably make my SPF algorithm run a little hot. So we simplify this by having an election called a designated router election. And this is based on something called priority. The higher the priority wins. And so you will want to line up your designated router with your spanning tree root and with your HSRP primary or your VRRP or primary, however you're doing that. And you might artificially set the priority to be extra high, a priority of 10. The default priority is 1, by the way. If you don't set a priority, it defaults to 1. If every router doesn't set the priority, they all default to 1, and then the highest router ID will win, which is a terrible way to elect your DR. So you might set something like this, where your DR gets a manual priority of 10, your BDR gets a manual priority of 5, half of the DR. This doesn't affect the algorithm. Really, all I'm doing is setting them both artificially high, but my DR a little bit higher, right? These numbers are kind of arbitrary. Everything else is what we call a DR other, meaning designated router other. And that could either be a priority of 1 or 0. I typically use priority 1, meaning I don't set any priority because the default is 1. But if your preference is to set it to priority 0, that's fine. A priority 0 means that those routers will not participate in any DR or BDR elections. The benefit of the DR and the BDR is I build all my adjacencies to the DR and the BDR, and the DR does all the updates. I update the DR is what updates the other routers, right? And it does so through a multicast mechanism, so it's efficient from a packet perspective. So we don't see a lot of networks like this anymore. They still exist for sure, but we don't design them much anymore. Let's talk about a special use case that's becoming more common as time goes on. And that's the point-to-point network. Now remember what I said on the last slide. The network type is based on the physical media of the interface. If it's an Ethernet interface, it's always broadcast. Right, to think about a WAN circuit these days. If you order a WAN circuit, they don't hand you off a T1 or a TDM type of circuit any longer. I mean, they could for sure, but 99% of the time, what do they hand you? They hand you an Ethernet, either a copper or a fiber, but something that plugs into an Ethernet interface, right? However, that Ethernet interface typically just runs between 2 routers. It might not literally be a physical cable like here, but it's often logically a physical cable like that. We'll talk a little bit about how to speed convergence in OSPF in several sessions from now when we have intermediary connections like ISP equipment. But anyway, so a point-to-point's a little simpler and easier to understand. It is literally a link that just runs between two routers. There's no benefit to having a DR-BDR election. Even if I have an Ethernet interface which supports broadcast, there's just two routers. There is no third router in this mix. There's no point to an election. It's just a point-to-point. You could think of it as I could, whether I do or not, I could configure this as a /30. I just need an address on the left, an address on the right, and I'm good. The way to do that is you override it at the physical interface level. You set IP OSPF network type to be point-to-point, and that drops the need for the DR-BDR election, right? And instead, I just manually form my adjacencies. I would recommend you do this on any WAN links that are running OSPF because WAN links are typically point-to-point, right? Even though they're going to be an Ethernet handoff. There's just no benefit to a DR-BDR. It's probably not breaking anything. It's just a little bit of a sloppy configuration, and I think we could all do a little bit better. So kind of keep that recommendation in mind. Let's talk about some special area types. The first one we'll talk about is stub, right? And a stub area basically does not accept external routes. And we're going to get into LSAs in a few sessions. I'll have a whole session that I just cover LSAs. But these next 3 slides are going to deal a lot with LSAs. We're just not getting into the LSAs in this part. I just want you to conceptualize what a stub area is. A stub area takes all of your OSPF routes, but does not accept any external routes. So for example, if R1 is redistributing a default route so everyone can get to the internet, and area 23 is a stub area, for example, right? Oops. Area 23 is a stub area, for example, it won't take that default route. Now you might think, well, that's going to be useless because I can't get to the internet. What it does instead is, instead of taking the external route, it generates a default and points it towards the ABR. If you recall from the very first session, I mentioned that these ABRs, they're really important. They're really critical. It's where we do all sorts of network manipulation and configuration, right? Because it's the border between two areas. And so I don't need to take in any external routes because the only way out of my area is through an ABR. Right? Recall, you can't leave an area except through your ABR, right? Your link state within an area, your more distance vector like between the areas. So I build a tree, it goes to my ABR. The ABR then is going to be on the backbone and much more likely to have full routes, including the ASBR route, which includes the quad 0, and I can get to the internet that way. So it basically strips all the external routes. Let's talk about a total stub. Total stub only accepts intra-area routes, right? So it doesn't accept external routes. It also doesn't accept inter-area routes. So if area 23 is a total stub area, the only routes it's going to accept are area 23 routes, just the routes that are locally generated in its area. All other routes, what's it going to do with them? Well, just like with before, it's going to send it to its ABR. Why? Because the ABR is going to have to, by definition, be connected to the backbone, and the backbone, by definition, is connected to all other areas, right? So you can kind of see what happens here is I reduce the routing table even more. I only have my local area routes. Everything else, I just say default it to the ABR, right? You might ask yourself, why would we bother with stubs or total stubs? This mostly comes from the era where routers had very limited memory for routing tables. And because OSPF is a distance vector and it's a scalable protocol, we would use it in our larger networks. However, sometimes we would find that the routers just couldn't handle all the routes in our OSPF networks. So we might configure them as stubs or total stubs, right? And that would reduce the size of the routing table. Because if you think about it, I don't really need all those routes in an area. I just need to know how to get to my ABR. I need to know who my ABR is because my ABR connects to everything else. Just remember, on both of these features, when you set a stub or total stub, you have to do it for every router in the area, and it will auto reset the OSPF adjacencies. Okay, so just keep that in mind. You don't want to do this during business hours. Get a window and do it responsibly after hours, right? The next one, there's actually two here. I'm just kind of putting it into a single slide. That's the not so stubby area and the not so stubby total stubby area. That's definitely my favorite. It just sounds funny to me. Not so stubby, total stubby. You take the concept that we had before of a stub or a total stub, doesn't matter. However, I'm going to add in an ASBR into that stub or total stub area, right? So you can see I moved my ASBR from R1 over to R3. And R3 is now redistributing a route. Let's call it a static route or something like that. Or it could have another router on the other side with an adjacency, but something external to the OSPF process. And I'm going to redistribute it into OSPF. So when I have a stub or total stub area and I redistribute external routes, that's called an NSSA or not so stubby area or not so stubby total stubby area, right? Now, you might ask yourself, why would you ever do this? It's a valid question. You should always ask yourself, why would I do this? I would also say you always want to ask yourself, what are the pros and what are the cons of doing something, right? Because every decision you make pretty much comes with a pro and a con. Here, though, the why is pretty simple. We usually do this to get through a temporary situation. For example, maybe R3, maybe there's some kind of acquisition. Maybe the company over on the left, R1, R2, has bought a company over on the right, R3, and R3 was already doing redistribution or something, or maybe they run EIGRP in their network. And until you have time to do a full network conversion, you need to bring some routes into your OSPF network. That might be why you have an ASBR in a stub area, right? Now, you could also just create it as an ASBR and strip out the stub or the total stub. That just depends on your particular network and what a lot of times we're inheriting these things, right? You wouldn't want to do this just because, although it's a great lab, and we will go through it probably in the next section, next session when we do labs. But it's kind of an interesting solution. This will make more sense. The whole how do stubs and total stubs and not so stubs work? That we'll get into when we get into the LSA section, probably in 2 or 3 sections from now. Next session, I think we'll do a lab so we can kind of see some of these items. As always, I want to thank you for your time, and I look forward to session 3 where we'll do a little bit of a demo / lab. Okay, thank you.
Need help? Call our cybersecurity team and book a consultation with us today.